Hey everyone, welcome to this tutorial session. Today we'll see how to integrate the Adyen API in a Java 11 web application built using Spring Boot. We'll also see how we can use the Adyen drop-in component on the client side to do online payments easily. So I'll be live coding this hopefully in an hour if everything goes well. So let's begin. Since we'll be using the Spring framework, we'll use Spring initializer to bootstrap the application. So let's head over to start.spring.io and bootstrap our application. So here, as you can see, we have selected a Gradle project for Java. We have selected the latest stable Spring Boot version 2.4.2, filled in some metadata. We are going to package it as a jar since that's the trend these days. And we'll be using Java 11, which is the latest LTS for Java. As for dependencies, we just need a few. We need Spring Boot DevTools, which definitely is useful in development as you can do live reloads, faster configuration reloads and stuff like that. We need Spring Web since we are building a REST API and a web application, of course. We also need TimeLeaf, which is a server-side template engine, which we'll use to render our client. So let's generate this. So I'm going to save this. Okay, let's unzip this. Okay, let's get into the folder now. Okay, let's initialize the Git repo to begin with. Okay, and I'm going to add all these initial files. I'm going to commit this now. Okay, so now we can start up our IntelliJ. Okay, we have our application loaded here. Let's see what we have. So, okay, here's our application. Of course, IntelliJ is doing some indexing at this moment. So let's, while the indexing goes on, let's add some log info so that we can clearly see when our application has started. So I'm going to add a logger. Let's import this. Okay, and I'm going to add a log so that we know that our server has started. So let's go in here and add something. Okay, so now we should be able to see when our server has started. Let's see if we can run this application. It's building. Since this is the first build, it's going to take a few more seconds than usual. Okay, our application is starting up. Yes. Okay, this is expected because we don't have any client-side setup, so this is fine. So let's move on and start building a client-side for this. So let's add TimeLeaf. I mean, we have already added TimeLeaf. Let's see. So we already have TimeLeaf, but in order to build further, we also need another dependency from TimeLeaf. So let's add that as well. So we would need a TimeLeaf layout dialect. I mean, this is not absolutely required, but for the use case that I'm building, I'm going to reuse some layouts. So in that case, this is required. So I'm going to add this and refresh my Gradle project. So in order for this to work, we also need to add a configuration. So let's go to our application and let's add a new configuration class. Let's call it config. Okay, yeah, so let's add a bean declaration here. So the layout dialect comes from the TimeLeaf dependency we just added, the TimeLeaf layout dialect. So it comes from there. So let's provide a new instance for that. Okay, so our config is ready. As I compile, as you can see that our application is reloading. So this is because of Spring Dev tools, which makes things much more easier for us. Let's go ahead and add some static CSS and images to our application first. So I'm going to copy it over from an existing application, the CSS and also some images. I mean, these are not important, that's why I'm not going to get into any details here. So I'm just going to copy what I already have. Okay, we have CSS and images, some like static stuff. Okay, let's now we have defined time leaf properly. Let's go ahead and create some templates first. So in order to use templates, we would need a layout first. This is the layout that will be used by time leaf to load all our templates. So let's create that layout first. So under resources templates, let's create a file called layout.html. This will be a base layout. I'm going to add some standard HTML5 template here. So let's make it more time leafy. So I'm going to also add the time leaf XML declarations here, the namespace declarations, so that we can use time leaf directives. Let's add a dynamic title so that we can provide title from a template if needed. Let's also add some CSS. So I'm going to add bootstrap CSS and also the CSS that we just loaded into static, this one. So I'm also going to load that here. So on the body, let's say add a header image. So I'm going to replace this with image again from the images that we already loaded here. So we have my store logo here. And for the body, let's go ahead and define our time leaf placeholder for the templates. So it will look something like this. We are using th block with the layout directive. We specify which fragments to load from the template. So any fragment that is named content will be loaded here. So let's go ahead and create our first template. So let's call it preview. So let's create a file called preview.html. Again, I'm going to paste some HTML content that I already have, because the actual content doesn't matter. What matters is that we build payment integration using the Adyen API. So we already have all the namespace declarations here. We have the layout decorate declaration on the header, and this is the actual content that will be used in the layout. So as you can see, this layout fragment is named content, so it will be used by layout.html to replace here. Okay. So just having the templates is not enough for us, because if we go here and refresh, it's still going to be the same error. That's because we are not serving these templates yet. So for that, we need to create a controller. So let's go back to our Java code. So let's create a new package called web, and let's create a controller. So new class, checkout controller. Nice. So let's mark it as a Spring controller, and let's create our first mapping. So we will create a get mapping for the root URL /. So this has to return a string. So let's call it preview, and let's return the name of the template that we want to load. In this case, it would be preview. So we don't have to provide the extension. Time leaf will figure that out. So let's reload our application, and let's go back here, and we have our page loaded. So the content of the HTML itself is not important at this point. If you want to look at the templates, you can always find them at our GitHub examples repo. For example, you can find the Java Spring example here, and you'll be able to find the actual code samples of whatever I'm using here. So let's get back to building our application. Okay, so now we have a preview page with a checkout button, for example. So now we have to actually make a checkout page. So let's create another template called checkout.html. Okay, again, I'm going to paste some ready-made content here. Nothing much here. The only important part is this. So we don't have much there yet. So let's add the actual stuff inside the container. So we'll add a class called div with class container and another inner div to hold our drop-in component. So here we are using, okay, let's just stick to ID because it's not a dynamic content, so it can just be ID. So we create a div with ID drop-in. So this is the only thing required to load our content here. So let's proceed to create our controller method. So again, get mapping. So this would be /checkout. So we are returning the template name checkout here. So we should be able to load our checkout page now, but it's not going to do anything because it's just a page with some div there. So it's going to be empty now. So we need to make sure that it can actually load the drop-in component. So for that, we need to create a JavaScript file first. So under static, let's say new folder, JS, and let's create our JavaScript file called adyen implementation.js, for example. It can be anything. You can name it however you like, doesn't matter. So let's add it to the our page. We only need it on this particular page, so we can add it somewhere here, for example. Okay, so we'll be loading it from JS folder under static. Okay, so let's create some method here. Okay, let's create an async method. We'll be using the latest JavaScript ES6 syntax. So we'll be using a lot of async await in order to keep the structure clean. So let's create our base method that we can load. So okay, this will be the method. Let's put in a try catch. Let's try catch our error, and let's put in some error handling, some basic stuff like console out for our error, and let's also just put in an alert so that we can see what happens if there's an error. Okay. Now we need to initialize this. Okay, so we have our JavaScript file ready. So now let's create the adyen drop-in configuration. So const config is equal to, okay, so for the adyen drop-in component, we would need a configuration, and there are certain things that is required for the configuration. For example, we need to specify a locale. Let's say locale US. Let's say environment is test. Let's say we load up a show like a pay button, and let's also create some payment specific payment method specific configuration. So in this case, it would be let's say ideal, and for ideal, let's say show image, so that we can see the like issuer image for ideal payments. And let's also do some configuration for card. Like, okay, we can have holder name as holder name to be true, so it has to have a card holder name. You can also do card holder name required to be true, so there will be a field for card holder name, and also it will be marked as required field. We can name it, and also let's set the amount that we are going to use. So this will be helpful in order to show the amount in the pay button. You can skip this, but it's useful just to show how these things work. So we have a basic config for us. So now the things that we, few other things that are important is we have to provide a payment response here, and we have to provide a client key. Client key is important for credit card payment. So for now we don't have them, so let's mark them as null. So we have our configuration object. Let's do a few more things here. Okay, in the configuration object we also can provide some function definitions which would be used as used on certain events. For example, we can define what happens when you submit. It has to be gets. So this would be state component. Okay, and similarly we can also have on additional details event. This is a call made whenever additional details are required for a particular payment. So we define these, and yes. Okay, now we have our configuration ready, but this is not enough, right? We still have to provide a payment method response and a client key. So let's see how we can get these. Let's go ahead and do some changes on our backend. So let's add a variable called client key, and let's load it from our environment. So Spring can load values from environment. So let's load a value called adyen_client_key from our environment, and also pass it back to our checkout. So for that we have to define a model. So this will be from Spring UI. Okay, and here we can say add the client key as an attribute or model so that it will be available in our loader template, right? So let's go back to our template and add a hidden div somewhere. Can be here, doesn't matter. So timeleaf will automatically assign that value to this hidden div. That means we can go back to our JavaScript and load this up. Let's try this. So we can get the client key by getting that particular div and getting its inner HTML. So that way we'll get the client key. So that means we can pass that as the client key. Now the only thing that we need is payment methods response. So let's see if we can get it from the backend again, but this time using a REST API call. So let's say we have another method that will do this call for us. So let's add await for that. So let's say call server, and let's say we call it from API / get payment methods. I mean, we don't have these endpoints yet, but let's just assume that we have. So that means we'll have our payment method response, and we can pass that here, right? Now let's go ahead and fill in these blanks because we made some assumptions. So let's go ahead and make those assumptions real. So the first thing that we would need is a call server function. So let's say we have this async function that can do a REST API call using the fetch API. So let's say await fetch, and the URL that we pass, comma, a configuration object. So method will be post, since most of our API methods are post for security reasons. Let's pass in a body, which would be either data that we pass. So if we have the data, then we need to JSON stringify it. So json.stringify data. If there is no data, then we'll just pass empty. And finally, we can also pass some headers for posterity. Let's say content type, application /JSON. Okay, looks good. So now we can do a fetch call here, but once our fetch call is successful, we need to return the response. So let's say return again await on the promise, because fetch returns a promise which needs to be resolved again. So let's say return await rest.json. So we have our call server function which will do a fetch call, but we still don't have the API endpoint that we defined here. So let's go ahead and create that. Okay. Let's create a new package called API. And let's create a class called checkout resource. As you can see, we are naming our client-side controllers as controller, and we are naming our REST APIs as resource. So that's just a naming convention generally used in Spring. So let's create our controller, our resource. So this will not be a controller. This will be a REST controller. So, and we can define a base request mapping, like a base path would be /API. So anything that goes to /API will be served by this file. So let's add a logger, because we would need a logger. Okay. Now, before we continue here, I think this would be a good point to add the Adyen API library. So let's go ahead to our build file and let's add our Adyen Java API library. So we can use the latest version, which is 11.0.1. So let's add this and let's refresh Gradle so that we have the classes loaded that we need. Okay. So before we proceed to create our API endpoints, let's initialize the Adyen server-side classes that is required, like checkout, for example. So let's create a private variable for that. Checkout. Okay. Let's create the checkout service, and let's initialize this using our constructor. So we'll be using constructor injection. So we would need a client. So we'll create a new Adyen client and we'll assign a new checkout using this client, a new instance of the checkout service using the client that we just created. Okay, oops. Cool, but the client is not completed. We have to pass API key and environment for this. So let's just say API key. Let's see, we will pass that as a variable, and let's say environment is test. Make sure that is test before you go with the live one. So we need an API key, and thanks to Spring, we can inject that using the @value annotation. Let's say inject it as Adyen API key, and this will be string API key. So Spring will take care of injecting this automatically, and we will have our checkout service. So before we continue, it is important that we set up all the environment variables. So for example, you can export the Adyen client key that we used earlier in our checkout controller, and the merchant account that we'll use again, and the API key that we just defined. So it's a good idea to export these in your environment or set up that in your IntelliJ run configuration, so that will be used. Okay, cool. Let's continue. So let's create our first endpoint. So I'm going to paste a snippet here. So let's say we create a post mapping for get payment methods, and it has to return a response entity as per the Spring REST endpoint schematics. So it will be for payment methods, and we already created, we didn't create a log. Let's create a log here. Okay. Sorry, I was using the wrong file here. Let me move it. let me move it to the correct one. So it has to be under resource. Cool. So post mapping, it has to return a response entity. Let's import these. I think it's okay. So we now need a request. So let's create a new payment request. Okay, so this is the Adyen payment request. So let's set merchant account, set merchant account. Yeah, we didn't define our merchant account, so let's go ahead and define it as well from environment. This will be loaded from environment as well. So we have a merchant account here, and let's say channel. So this would be channel web. So payment methods request channel enum dot web. Okay, we are set. So now we have a request that we can use. So let's say response is equal to checkout dot payment methods with our request, of course, and we will just throw the exception so that Spring would automatically handle it. And for the response entity, we will just pass the response, and let's say our response here would be, so it has to be the same type as whatever response we are returning. So in this case, that would be payment method response. So let's define the generics there. Methods response. So we have our first API ready. So let's go ahead and load up our application now. Refresh our application. Let's go to checkout. Nothing is loaded, but we can see that network request was made, and it has responded with payment method. So our API, whatever we added now, is working fine. So now let's go ahead and fix the issue of nothing loading up here. So that's easy to fix. So we need to add the Adyen resources. So that is the Adyen JS and CSS files. So let's go to our layout file, and let's add our CSS. Sorry, that was a JS. Let's add the CSS, and let's add also the JS file. Let's say we can also add it to our specific HTML here, so that should also be fine. So yeah, let's do that. And we need to now, so we have defined our configuration, but we haven't mounted the components yet. So let's go ahead and mount the checkout component. So let's say const checkout is equal to, okay, we have to create a new Adyen checkout instance here and pass the config. And now we can use this instance and create our drop-in component. So let's say create drop-in and mount it. So in order to mount this, we can use query selector. So get element by ID. If you remember, we already defined a container here with an ID drop-in. So we'll mount the same here. So that should be enough. So let's say, okay, let's try this out. Okay, there is an error. Let's see what was wrong. Cannot read property filter of null. Yes, so this is expected. In order to fix this, so actually what happens is that some of the items which was responded from the API call might have null values. That's because that's how it is sent from the Java library. So in order to do that, in order to mitigate that, what we need to do is we need to set a json property. So we use json as the json serializer and deserializer. So when the object that is sent by the Java IDN Java library contains null, Jackson just sends it, stringifies and sends it as it is. So we need to tell Jackson not to do that. So what we would do is, under resources, application property, we will say Jackson default property inclusion to be non-null, so that only non-null values will be serialized and deserialized by Jackson. So this should fix our issue here. So the application has reloaded. Let's try again. Yes, as you can see now, the drop-in component has loaded, and it's going to show up all the payment methods that you have configured in your customer area. So for example, in my customer area, let's go to my customer area. Okay. So let's go to payment methods here. So for my account, so I have defined all these payment methods, and that's why all these show up. So if you have defined, for example, just credit card and maybe say ideal or Giro, then only those will show up. So we still haven't defined the behavior on submit and additional details. So let's go ahead and define those. So if the state is valid, let's say we call something like handle submission, and we pass the state component, and also let's say we specify which URL to call. So in this case, let's say we call APIs/initiate payment, like this. Right now, let's create this method. Let's create the handle submission method, because we don't have it now. So it will be an async method which takes the state and component and URL that we passed. So within the method, we can again reuse our call server function here and pass the URL along with state.data, because state would be passed by the drop-in component, and it would contain the data required for the payments call. So let's pass it here, and we are not handling the response yet, as you can see, and some standard error handling here. So this should allow us to try to make a payment at least. So let's see if we can proceed with that. So we need to create this API first before we can continue. So let's go ahead and create that. So let's go to our API and let's create a new one. So initiate payment would be, so this would be our initiate payment API, and we need to create, so first we need to get the data that is sent. So let's say request body. It would be payment methods, payments request. So it would be payments request, and yeah, payment request. So this would be responding with payments response. Let's try to find it. Yes. Okay, so let's create our actual request. So we can create a new payment request object, and we need to set some standard things like merchant account and channel. So let's do that as we did in the earlier call. So we also have to set the amount. So it is always a good idea to do this from the backend, so that you can avoid any kind of man-in-the-middle attacks, stuff like that, especially for amount. It's always good to calculate this on the server side. So let's say currency is euro, and let's say value is 10 euro. So that would be 1000 in minor units. So that's long value. So let's set this payment request, set amount. We also need to set a reference. So let's set a payment reference. Set reference. Okay, for this we can create a unique ID. So let's create a unique ID. So we can use the UUID module, this should do. Okay, we have set a reference. Now we need some data from the request that was sent. So let's get those. So we need browser info, we also need payment method, okay, so that should be good. This should be good enough. So let's make the actual call. So this will be payments with payment request, and we pass the response back, and of course handle the errors. So add exceptions to the method signature, and voila, so we have our initiate payment API. So let's compile, reload. So let's see if we can make a payment. So let's refresh this first so that our client side changes are loaded. Let's go to credit card. Okay, it's trying to load up the client key configuration, I think. Okay, let's go with the credit card. So this is a test card. You can find this in the Adyen documentation site, all these test card and test data. So let's try. So we made this request and it has returned as authorized. So it seems our API is working, but we haven't, we didn't handle it on the client side yet. So you can see on the server side, the request has went through and it has responded with success. So the result code is authorized. So the payment was accepted. So let's go ahead and handle it on the client side as well. So let's say handle server response. That means we have to create a new method for this. So let's go ahead and do that. So a quick note. So if you are using Java server library version anything prior to 11.0.1, then while doing this, you might get a deserialization error, especially with json or json. You might get an error if you try to use payment request directly like this, from try to deserialize or serialize it from the request. So in order to handle that deserialization error, you would have to define your own custom JSON deserializer, either for Jackson or for JSON. So it would look something like this, for example. So you can see here, you can see that we have our own custom adapter on the latest version. So you can also just try to create something similar. So this one is for Jackson and this is for JSON. So you can look at the latest one and try to do something like this in order to handle the deserialization. So this would be applicable only if you are using a version below this. So 11.0.1 onwards, it should work fine. So let's go back. Yeah, let's go back to creating our handle server response function. So this has to take a res and component. So let's add that. So if we get a response, what we need to check is if the response was successful. So there are two options here. So if the response has an action object, then it means there are further actions required. So what we can simply do is we can use the component that is passed here, that was passed from the submit event. So this is the actual drop-in component itself, instance, the instance that we used. So we can use the same component and we can call a method called handle action on it. So, and just pass the action from the response to it, and the drop-in component would automatically handle whatever needs to be done for that particular action. For example, if the action was a redirect, it would automatically trigger that. Or if the action was, for example, 3ds to fingerprint or 3ds to challenge, the drop-in component will automatically initiate the required steps. So if there are no action, then it means the request was either successful or it failed. So in that case, what we can do is we can say switch on it, switch on response dot result code. So switch on it and let's handle the switch conditions. So if it is authorized, we can say just simply load a success page, for example. So window dot location. Let's say we load /result/success, for example. I mean, this is where you would be doing your own custom logic to handle success or fail scenarios. So let's say break, and let's also handle pending. So pending, and also refused cases. So that will be the equivalent of failure. So we can send them to the fail page, and by default could be error handling. So this should be enough to handle the response for these requests. So let's try again. Oh, before that we need to add the result page. So let's also do that. So I'm going to add a pre-built result page to our templates. So file result.html. So yeah, nothing like major here, just some conditional statements to handle the different kind of error or success scenarios. And for this page to work, we also need a controller method. So let's go ahead and add that in our checkout controller. So we take a path variable here, which is the type, and we set the type back as well, so that we can use it in the page to do our if else conditions and stuff like that. So should be good. Let's try again with the test card. Let's reload again. Okay, credit card. Yes, so this was a success case, so it went back to the success page. So I think we are good here. So far we have implemented the drop-in component on the client side. We have created some APIs using the IDE and Java library on the server side, and we are able to successfully make credit card payments so far using the IDE and drop-in component. So let's go a few steps further, and let's see what else we can quickly add. So let's say we want to make ideal payments. Let's say we want ideal payments, which is one of the most popular payment mechanism in Netherlands, where I live, for example. So let's try this. It's not going to work, right? So similarly, if you try some other payment methods like Klarna or local Polish payment method or something like GiroPay, it might fail, because so far we have only made sure that the credit card payment mechanism works, right? Because there are more fields that needs to be passed for certain payment methods during a payment request. So let's say how we can fix the ideal case, for example. So it's quite simple actually. So we just need to add one particular field here. So let's go ahead and add that. So payment request dot set return URL. So the reason for this is ideal uses something called redirect during the payment request. So when you make a payment request, it is not directly accepted or refused. So instead you have to go to the ideal issuer website to do further action. So the payment response here would contain an action with a redirect step to be done. So that is why this particular thing was failing for us, because we didn't define where to redirect to. So let's say we set a return URL, and in this case we need to set our own server, which is this. So localhost. So this would be your actual server URL in real scenarios. So, and let's say in order to identify our request, we can add a custom identifier, like a say order ref, for example. So we pass the dynamic order ref. So this will be passed back as well, so that we can identify which request this was triggered from, this return was triggered from. So as you can see, we set this, so this would be enough on the payment request side for ideal. But as you can see, we defined a URL that doesn't exist actually. So that means we would have to go ahead and create this particular URL. So let's do that. Let's So we are creating a get mapping here, call it redirect, whatever, right? So we are expecting certain parameters. For example, we are expecting payload to be passed. So this is passed by Adyen during this request, and we are also expecting redirect result to be passed and an order ref. Actually, the payload part is in older version of APIs, and since we are using the latest version, we can actually get rid of this. We only need the redirect result, which is like a replacement for the payload part. So we would get the redirect result from the URL and also the order ref that we were passing. So this would handle some exceptions as well, as you can see. And this redirect, once we handle the redirect, we have to again redirect back to our application. So we would send a redirect view instead of a response entity here. So let's go ahead and handle this. So let's first create a details request. This is because whenever you handle an action, most probably you'll be calling the submit additional data endpoints or details endpoint. So that is why we are creating the details request. So in this case, we have to set the redirect result. So we would first check if redirect result is present, and if it is present, we can just create a singleton map and set that as the detail request. Right now, let's say we have our request and we can handle this in a method. So let's say return get redirect view, and let's say we pass the details request. So we don't have this method yet, so let's go ahead and create this method. Fine. So for the details request to be complete, we also need to set payment data for this. So how do we get payment data? So this is where it gets interesting. So there is a reason we passed order ref in our request. So the reason is that payment data is actually present in the payment request itself. So how do you pass that from the payment request to the redirect request in a stateless system? So one of the way to do that would be to save it during the payments in your database with a unique identifier. In this case, that would be the order ref, and fetch it using the order ref from your database during the redirect. So to make it simple, in this case, I'll just use an in-memory map to do that. So let's say in a payment request, once we get a response, so I'm going to check if response contains action. And I'm also going to check if action has payment data. So if payment data is present, I'm just going to set it to, let's say, a map, payment data store. So we don't have a payment data store, right? So what I'm going to do is I'm going to define a map, a private variable for this particular instance. So let's say private map equal to new hash map string. So this would do for now. So let's say put order ref, which would be unique for each payment request, so we can use the same, and we'll get the action dot payment data. So now we are saving all the payment data from the payment request in an in-memory map, so that we can retrieve that during redirects using the order ref, right? So let's retrieve that now. Payment data store dot get order ref. That's it. So this should, what's wrong here? Interesting. I think probably, yes, because we didn't pass the generics here. So let me just fix it. So we don't need this actually. Java can for that. So it should be good now. Yes, it's good. So now we need to fill in the get redirect view method. So let's go ahead and do that. So let's add a log statement, and let's call the details API using the request first. Let's handle the error. So we have a response. So what we can do here is we can do something very similar to what we did on the client side. So we will just check the result code and redirect to appropriate URLs. So let's say redirect URL starts with result, and let's do a switch case. Let's do a switch and on result code, and based on the status we can append the relevant URL which we have already created using the result HTML page. So this should be enough, and for return we can create a new redirect view with redirect URL that we created, and yeah, I think this would be enough. Okay, let's try it out. Let's see, ideal, select an issuer, continue. So this is the redirect part that we configured. Okay, there is an error, but if you look at the URL, so the redirect from issuer has been sent back to our own URL that we provided, and you can see order ref being passed here. Now let's see why there is an error. So it says missing payment method details. Let's see what was passed. So we have okay, so we have order ref and payload, not redirect result. So most probably because of some version issue. Let's see. Okay. Okay, I think the change from payload to redirect was in a recent version. So let's just use the latest version of the CSS, and I mean CSS shouldn't matter, but just for consistency I'm upgrading to the latest ADN CSS and JS. So let's also update the latest JS here. Okay, let's also update our Java library to the latest version. So let's go here. So let's see what the latest version is. Okay, we have a newer release, so let's update to that. Let's update to 12.0.1. Reload here just to be sure. So okay, let's wait for it to reload. I'm just going to restart it. It's not reloading for some reason. Yeah, because there was no classes changed for the automatic reload. Yes, sure. On the main classes, and this class load change wasn't registered yet. So okay, sure. Let's go back. Let's go back. Okay, let's try again. Ideal. So this is the redirect part again, and yes, so it works. Let's also check refused situation for ideal. Let's say refused. Okay, and yes, so our ideal part seems to work fine. So now let's go back and see what else we can do here. So some of the payment methods like ideal would be using a get redirect, whereas for example if you're doing a 3ds2 or if you're some other payment methods, it might be using a post redirect. So you also need to add a post redirect handling here. So let's go ahead and add our post redirect handling. I'm going to use this snippet which I already have. So as you can see here, compared to our get redirect, we are declaring this as a post mapping for the same URL, and we are also declaring the media type that it needs to consume. So this part is very important because when IDN redirects using post, there are two fields, MD and PARS, which are sent as form URL encoded values. So you have to declare this, else Spring by default would try to process post body, so and it would fail. So this is important. So in the method itself, we can add these as request params. So MD and PARS can be request params, so that we get it from the form encoded values. And we also have the order ref similar to the previous request. So now let's go ahead and create our details using these. So details object would be a hash map. So we have to add MD and res into it. So once we have that, we can create a details request. So we have a new details request. Let's set the details object. Okay, so with this, we can now set the payment data similar to what we did in our get method as well. So it should be the same. So now we can reuse the method that we already have using this details request, and that's it. So we now have ability to handle post redirects as well. So we can test this out using a 3ds2 redirect flow. In order for 3ds2 flow to work, we have to make some changes to the payments API method that we implemented. I need to change this to redirect. I think that is a copy paste error. So let's go ahead and make changes in our payments endpoint. So let's do that. So let's say we have to set additional data. So we have to set an additional data where we enable 3ds2. So by setting this additional data, we are enabling 3ds2 here. So the next would be we need to set origin, which is important for 3ds2. This is required for 3ds2. So for this use case, we can set origin same as our local host. In our actual use case, you would be setting origin of the website where we would be running this. We also would have to set shopper IP, which is required for some card issuers. So let's say we can get the shopper IP from request. So let's say http request. I think we can get it from http request. Let's try that. It has to be http servlet request, actually. http servlet yes. So let's try to get it from http servlet request. Request.get remote IP. Yes, I think this should do. So we are getting the remote address from the HTTP servlet request. In actual use cases, you can get the actual IP using much more efficient ways, I think. So let's reload this. Okay. There is one more step that we need to do in order to handle 3ds2. We would have to define a URL for additional details. So remember this part. Remember this. So we haven't done anything here yet. So let's handle this. So this would be when there is an additional details, it will call this endpoint, and we have to add that here. So let's go ahead and add that. It's a very straightforward request. So this is a very simple request where we will get the request body and call payment details and just send the response. So very straightforward. So save, done, and let's reload this, and let's try to make a 3ds2 payment. So I'm going to use a 3ds2 test card this time. So let's try credit card. Okay, I think something went wrong. Oh no, it was just slow. Okay, credit card. So this is a 3ds2 test card. So let's try. We should get a 3ds2 challenge. Yes. So let's submit that. And yes, so seems to work well. I mean, our native flow works. So that means it was using this URL to do additional details call. So now let's see if we can get our post redirect also checked. So for that, we would need 3ds2 redirect flow, not the native flow. So how we can achieve that is we can go here and we can, let's say we can comment out the origin, and when origin is not present, so 3ds2 flow falls back to a redirect flow. So let's try that. So reload. So I'm gonna do 3ds2 request again. Okay, this should be redirected. Yes, so as you can see, we didn't get this within the application, so it was redirected to ADN URL for authentication, like 3ds2 challenge, and it was redirected back. So our post redirect was successful now. So far we have successfully created a payment integration in our Java Spring application. We use the drop-in component. We are able to make credit card payments. We are able to make payments with a get or post redirect flow. We are able to make 3ds2 payments. So that's it for this tutorial. I hope you found this useful. If you have questions, please feel free to make comments on the YouTube video. You can follow our Twitter handle for updates. You can also sign up to our newsletters, and you can always contact us using our developer experience at adn.com email address. If you have suggestions, feature requests, you can always go to our forum and you can make suggestions for those. So have a good day, everyone. Thank you.